Hi, I just wanted to do a quick video about hand assembling surface mount boards. There's lots of tutorials about this on the net, so I just want to focus on a few sort of random hints and tips, particularly aimed at where you've got quite a lot of boards to do or a lot of components. Now, although I've actually got a pick and place machine here, which I'll probably do some videos on it in the future, if you've got quite a high mix of components and they're not already loaded on the machine, the actual time to set everything up, set the job up, load all the components on the feeders can actually be longer than it would take to hand assemble a few boards. So particularly if you've got quite a wide mix of components, say for example you've got 20 boards and there's like 10 different components on the board, but also you lose quite a lot of components, for example the leaders on the tape. So for short runs I still tend to hand assemble, so I was going to sort of present just a few random hints and tips that you might find useful that I haven't really seen mentioned anywhere else. What I'm going to talk about is situations where you've got quite a lot of components to put on, like tens, hundreds, even low thousands to put on by hand. The traditional method is just sort of take your piece of tape, empty out your components, get your tweezers and start putting them on the PCB. Now there's a few problems with this. Firstly, half of them end up the wrong way up, so you've got to flip them over. One way around the problem of them coming out all different ways up is if you actually put a piece of paper on the bench or a piece of card, then just a little gentle tap will flip them over. And of course they're all at completely random rotations, so you've got to sort of each one you've got to get it the right way around, and it can end up pretty fiddly, especially when you also need to make sure that your finger's not going in all the solder paste. There's no paste on this board, but normally this would be a pasted board. Another big issue with doing this is polarised components. LEDs, diodes, LEDs, anything where it actually matters which way it goes round. Things like diodes have quite often got a mark on the top, but they're often laser marks and actually quite hard to see. But LEDs, for example, these ones, you really can't actually see which way around they are from the top. They've got a marking, like an arrow mark on the bottom, so if you just empty a load of these on the bench, it's a real pain to make sure they're all going on the right way up. Another problem with doing it this way is you empty a load of parts onto the bench, stick them on your board, clear out any that you don't use, you get to your next component, do the same thing, but there's always a risk that you might have missed the odd component from the previous tape, so there's quite a risk of misplacing parts unless you're really thorough. Make sure you clear the bench every time. There's quite a risk of getting components a bit mixed up. The problem with tape is you can't really get parts out of the tape with tweezers. There's just not enough space. You get the occasional one, but you just can't do it reliably with every sort of tape. So what you really need is a vacuum pickup tool. Well, you can buy tools like this. They're pretty cheap on eBay. They've just got a simple vacuum, finger operated vacuum pump. The problem is these are almost useless. They're just, there's two reasons. One is they don't give a continuous vacuum. The second is that when you're trying to place something accurately, the last thing you want is a button on the thing you're moving. They're just about usable for things like QFPs because you've got a nice big flat surface. But the problem is, you're trying to align it super accurately, and then as soon as you want to release it, you press the button and the thing moves. The other thing is, for small components, these suction cups are just too big. You really need something much smaller, like typically just the bare end from a dispensing needle that's been bent into the right shape. And of course, because there's no rubber on there, you don't get, this thing's not going to be any use. You need a continuous suction from it. However, you probably should actually buy one of these. The reason is they provide a nice source. You usually get a few tips from them, so it's a good cheap source of the little vacuum cups, and you got the handheld thing. Rip out the vacuum pump, stick a bit of tubing in there, then you can connect that to a simple vacuum pump. If you want to be really cheapskate, you can actually just put a tube through and have a little hole, almost like a musical instrument, where you put your finger over it to get the vacuum, and you can just release your finger and then that will release the vacuum here because the air's all going in here. But ideally what you really want is a foot operated switch. You can pick up solenoid valves fairly easily. It's not particularly difficult, but it just makes so much difference having be able to turn the vacuum on and off without any hand movement at all, especially when you get onto the finer pitch stuff. And of course, if you're a real cheapskate, there is another alternative to using a vacuum pump. But if you're just doing one board or just a few components, what I normally do is just get some of this double-sided sticky tape, very thin film tape. Just stick a little bit down to the bench, peel off the backing tape, and then just stick your tape down to it. and just peel back however many components you're going to use. Either trim off the lead or just put something on top of it. Turn on my quite noisy vacuum pump. Now now things get a lot easier, because now you can use your vacuum tool, you can just pick the part straight up, you can align your board to be in the same orientation as the component, and of course now this also solves the problem with polarised components, because they're all going to be in the same orientation. So I can just pick the parts straight out the tape, straight onto the board, really quickly. So these are falling all over the place because there's no paste on it. But when you're doing repetitive components, it's really quick. This needle, this is actually a standard dispensing needle that I've just bent it around with some pliers, gently bent it to get a nice working angle. This I think is about a ½ mil or something. The size isn't too critical, but it needs to be small enough that you can actually see all the way around the component, so you can actually see where the pins are going on the board to get it nice and lined up. And you find a needle like that is actually good for most sizes. You can even do larger packages if you're careful. They tend to fall off a little bit, but you can even get up to big packages with that single tool. One thing to watch when you're sticking down plastic tapes quite often have little holes in the bottom, and sometimes if you press it too hard down on the sticky, you'll find you'll occasionally get some of the sticky will sort of splurge through, and it will actually stick components down and stop you lifting it. So just be a little bit careful, particularly things like smaller capacitors, 0805 capacitors. Tends to do it a little bit, so with a bit of practice you get the hang of how much to stick them down. The other word of warning is don't stick down more components than you're going to use, particularly on a paper tape, because the problem is that when you then peel it off again, it will sometimes pull the backing off the tape and you'll lose the components. Plastic's not a problem, plastic ones will come off quite nicely, but paper tapes, they will sometimes peel the backing off, so don't just stick a huge great long piece down if you're only going to use a few components. One thing about QFP packages in particular, they're pretty much impossible to handle with tweezers, because you're at risk of bending the pins and it's very hard to actually get hold of them well enough. Here's a trick if you don't have a vacuum pickup tool. Just get a screwdriver or some other tool, put a lump of blue tack on it, and now you've got a nice pickup tool for almost no money. Obviously you need to hold it down to release it, but the chance are a lot of the time what you're doing here is you're placing it and then you're tacking a couple of pins down to hold it in place before you let go anyway. So that's just quite a handy little tip for doing say QFPs in particular, things that if you don't have a vacuum tool, things that are difficult with tweezers. Poor man's vacuum pickup, lump of blue tack and a screwdriver. If you're doing quite a lot of boards, quite often you don't necessarily want to do one tape and do that component on every single board, because there might just be too many boards on the bench. What I like to do in that situation is just get a few little pieces of wood or plastic and stick down each component that's used in that job. Then you can have sort of multiples, you can move them around, they're not in a fixed place, so you can do one set of boards, put it to one side, get the next board ready and get the channel. But also there's another nice thing is you can rotate the whole lot, so you can maintain the same rotation, because it can be a little bit fiddly rotating when you're placing, so it's much better to actually have it always in the right rotation. Right, so just peel the backing off, so we just stick each component down. Use a sensible order, so for example put resistors in ascending order or in order of component reference, just some way that's a vaguely logical layout. The reason I like using the wide stuff rather than the thin stuff is that when you peel the backing tapes back, you can actually just tack it down to the residual sticky, so you don't have to keep trimming the backing tape off. You can actually tack it down, so you peel off the strips peel off enough strip for however many boards you're doing in one go for that component, and you just peel it back and just tack it down. So with tweezers that's very quick to do. Alright, so you've got all your parts laid out ready to use. Obviously the ends are all labelled up. So you don't want these boards to be too wide. If the board was sort of this huge great wide one, you'd be reaching a long way over and you'd risk sort of granching the solder paste with your arm. So what you tend to do is place all the parts of one value at a time. So if you're building, say, a set of 5 boards, you peel back enough parts for 5, do all of that component, then do all the next component, and because you're doing the same component, it's the same location on each board, so it's you're less likely to get it in the wrong place. One thing to remember is you don't need to be super accurate when you're placing parts. As long as they're at least 50% over the pad, when they're reflowing they'll actually draw onto the pad and snuggle down and end up all nicely lined up, even if they weren't placed particularly neatly. A few quick words about solder pasting. If you're doing more than a few boards, it's definitely worth getting a stencil done. This is a simple polyester stencil, costs about 13 quid for a sheet that big, so you can get quite a few boards on one sheet. It really makes it a lot quicker, but also you get a much more consistent solder paste print. Barring that, what you really need is some sort of solder paste dispenser. Now, solder paste normally comes in syringes like these. It's called Lure-Lock syringe, because that's the name of the coupling on here. They take standard needles. You can use these just with a simple plunger. The problem is that you're trying to get fairly accurate positioning, and because the solder paste is fairly gloopy, you need quite a lot of force on the plunger, so it's actually quite difficult to do it accurately. What you really need is a foot operated compressed air dispensing system. These are meant to use couplings like this. Actually I've got this as a spare part for an expensive dispensing system, but you can buy dispensing systems. There's some Chinese ones which are fairly cheap, but there is scope for improvising. For example, here's a syringe coupling I did for another project. This is just simply a piece of tube going into a grommet and a little retaining clip made out of PCB material that will hold it on, so the syringe coupling is fairly easy. What you then need is either a solenoid valve or a foot operated air switch, which applies the compressed air to the tube to push the plunger down and then releases the pressure. You need to actually have a second solenoid to actually depressurize it, otherwise it keeps squirting out. The other thing you do need is a pressure regulator. These are fairly common parts for pneumatic systems. They're not too expensive new. You may be able to use second-hand ones, or you might be able to adapt something, for example like a gas pressure regulator or something, but you do need to be able to control the amount of pressure, because that directly controls the amount of dispense, the speed that the stuff comes out. So the combination of the thickness of the paste, the size of the needle and the pressure gives you your dispense rate, and it is quite important to get it so it comes out fast enough, it doesn't squirt all over the place. That is quite important. What you don't particularly need, a lot of the commercial expensive dispensing systems have a timer, so you hit the button or press the foot pedal and it gives you a shot for a specific amount of time. That's not really that essential. You can easily do that sort of manually. You get a feel for what length of time you need to do it, so that's less essential. Another option to the solenoid valve with something like this is actually a foot operated air switch. So this just directly switches the air, so you don't need a solenoid. As for the source of compressed air, I've just got this little compressor down here, but because the air volume is so low, there are other options. One is just I've seen some online published design with using an air duster canister, but also I've used a soda stream cylinder in the past as a source of compressed CO2. Right, with the foot pedal control you can easily control the size of blob that you get, but if you get the flow rate right, you don't even need to do it in separate shots. You can just continuously supply air and then just dab on each one. If you just get the flow rate and the rhythm right, you can paste up boards really quickly like this. The other thing is, with stuff like SOs, which isn't very fine pitch, there's no real need to do each pin. You can just do a sausage right along the length of the chip, and because the pads are fairly small compared to the distance between them, that will actually ball up onto the pads and that will reflow without getting any shorts. There's lots of stuff on the net about reflow ovens and hot plates and so on. I'm not going to say too much. This is what I use most of the time. It's a Sanyo oven. Nicely, it's got elements top and bottom. I actually run it off a Variac, which is totally overkill, but I just happen to have a big Variac. You can use a trike controller, like a stage light dimming controller, to adjust the temperature. I don't mess about with temperature profiles, I just turn it on at about 60% or so. A good tip is, if you turn it on so that the elements are not just below the point where they start to glow, you don't want too much infrared, because that can scorch the board before the whole board's heated up too much. And you pretty quickly get used to how long it takes. Reflow is typically about 3 or 4 minutes. I use this little timer to remind me, because that 3 or 4 minutes is the sort of length of time where you get bored and go do something else and then forget about the board, and then you suddenly smell burning. So just something to beep you when it's about to reflow, and that's really all you need. You don't need to really mess about with. If you want something completely automatic, then yes, get a PID controller, but you know, I've done hundreds of boards in this oven and not damaged a single one, so you don't really need to spend a lot of money. For bigger boards that won't fit in the Sanyo oven, I use this. This is a commercial pizza oven. It's about a 3 kilowatt oven. The only thing I've done to it is I've replaced the original sliding drawer with this window. This is made out of stove glass, which is a special heat resistant glass. It's not at all expensive. I think this piece of glass cut to size was, I think, less than £10, so it's not at all expensive. And I've replaced the tray. This is actually an adjustable oven tray. It's not really quite big enough. I'm going to have to, I think I'll braise up a decent tray at some point, but it does work reasonably well. It's got, again, like the Sanyo, it's got elements top and bottom, you can't really see very well. It's 3 kilowatts. It's a little bit on the slow side, it takes about 5 minutes, but it does the job. I've done some fairly big boards in here.